Thank you for having me. Thank you for arriving here in lovely Berlin. I'm delighted to be here with you in person, and for those streaming, thank you for joining us as well. Wow, it's really bright up here. I can barely see any of you. I'm delighted to represent NVIDIA here for confidential computing. It's certainly a topic that I'm passionate about. I helped instigate confidential computing in the GPU at NVIDIA. I also have the good fortune to be able to talk about NVIDIA and AI and confidential computing a week after GTC, where Jensen Huang spoke at length about what NVIDIA is hoping to see in the next coming years. So conveniently, I get to steal a slide, so that makes it very easy for me to talk about where we're at today. And we're going to ground our story in AI, because I think it's really a strong motivating example for certainly a lot of what we're doing at NVIDIA right now, but also where I think a lot of the industry transformation is going over time. And as part of that journey, just to sort of get us up to today, I want to start with where did NVIDIA's mission for AI really emerge? And if we look here down on this far left pre-training scale, we had this thing which we call perception AI. This is sort of AlexNet leaping back 10, 12 years ago. And for those not familiar, AlexNet was really just sort of an image classification neural network. But what we saw inside NVIDIA was something slightly different. Yeah, it was an app. It worked really well, and it fixed problems that for decades had been challenging. But what we saw was the fundamental observation that you could take a lot of data using a dense parallel computational algorithm for learning and create a function to solve that problem. And in fact, we learned in that moment that you could encode almost any function with this strategy, this generalized solution. And we had this observation that the future was going to be different. This is 2012. The way we write software, the way we integrate with technical systems was going to change forever. And we ran away with that, right? We had CUDA language on the platform. It was the most valuable and used parallel programming paradigm on the planet, accessing the most powerful parallel engines on the planet. And we started investing in the most capable and flexible AI software stack to go with that. Fast forward a couple years, now we're in this generative space. And notice in 2012, we weren't thinking about confidential computing. But as we get to the generative space, we're talking about 2018 GPT-1. Suddenly, the rest of the world is starting to catch up to the notion of what AI could really be. And we had a different observation at that moment in time, because the generative models were actually getting kind of large. But in order to realize the vision of AI, you had to get the data in the place to do the training. And it turned out a lot of the GPU capacities were not where the data was. A lot of the most valuable, most influential data that you'd want to use in these AI models is on-prem in your data center that largely didn't have the capacity of GPUs to go train an AI. We had a fundamental problem. And with GPT-1 following fast on the heels of GDPR, where data processing and the regulations come with it became front and center, it became very clear we need not just scale of compute, but we need trust. And how do we build trust into the environment? And it turns out Hopper, confidential computing, came out of that fundamental observation around 2018. And we did a quick pivot and invested in confidential computing architecture and ultimately delivered that to market in 2012, well, the device in 2012 and confidential computing support shortly thereafter in 2023. And already we were observing changes in the market. People had taken with AI and run away with it. We'd gone through evolutions of GANs and VAEs and transformers, and now generative, and we're continuing to evolve on the platform the next generation. And that's where we go from generative to our single CPU solution, but the generative models were now much more capable, and we found a different scaling problem. One GPU running SPT, confidential computing, wasn't enough. Now we needed more, and we started ganging together with protected PCIe solution into the market, 8 of these together in a single node to enable us to continue scaling. Fortunately, our team who are actively delivering Hopper were also working on the next generation architecture. And that brings us largely up to today. We had this challenge. AI was going to be a problem for not just regulated industries, but any industry. And we needed scale and trust to get there. We delivered Hopper. We had confidential computing. We had some scale. We needed more scale. And that's where we get to agentic AI. This is sort of the next generation. This is the more current, and certainly where Jensen spent a fair bit of time at GTC talking about. And there are 2 major factors there. And I'm going to get very repetitive because I'm going to talk about these words again and again. But when we look at agentic AI, the models that we're seeing now aren't sort of the generic one-shot generative models that we did. You'd sort of take 100 tokens, you'd put it in, maybe get 300, 400 tokens out, one pass, very straightforward. Really impressive results, but largely shallow thinking. And when we see agentic today, and the models that we see, the more modern models today, they're much more advanced, they're much more complex, and they're taking long, sort of reflective methods of thinking or chain of thought thinking, mixture of experts type thinking, where we take 100 tokens, we convert it into many subtasks, sometimes calling tools to collect data from local data sources, going out to the web, collecting other data, adding it into the mix, sending it to subtasks to find 4 different solutions and pick the best one that we want, or maybe compare them to see, is our reasoning stable across different thinking methodologies, sending it back through our verification engine. So instead of 100 to 400 tokens, we're talking 100 to 1,000, 2,000, 4,000 tokens. So we've just 10x'd the amount of volume that we need. Hey, we need more scale. And we're using more complicated models that take 10x the compute to keep the latency and throughput that we need. So we're talking about 100x demand and scale just from a couple years ago. And as ambitious and optimistic as NVIDIA is about AI, I don't think we anticipated how fast and far these models would actually go. So we're in this land of agentic where we need 100x scale. The interesting thing about agentic also, though, instead of the single model, we're now running potentially multiple models from multiple people, potentially running in multiple clouds, accessing data from different locations. So in negotiating this notion of trust in an agentic form is now also much more complicated. So as we scale up compute, we also need to scale up this notion of trust. And that's where confidential computing, the attestation primitives that we've talked about, and we're so powerful, even in this more limited generative case, now comes roaring to the front as absolutely necessary to achieve what we need in this new agentic space. And Jensen, always the forward thinker, is looking also at physical AI. So now take that agentic case and make it more mobile, more varied in form factors, pushing it out to the edge, sort of the next stage after that, more trust, more scale. So what's our solution? And you can sort of see the leading indicator up here. It's Blackwell. We just launched it a few months ago. We've already got about 4 million devices in the field with primary CSP partners as well as devices at the enterprise. And it's really just building the foundation for the future of AI and AI-generated workloads. We obviously start with security. We know and love the Blackwell family has the same confidential computing foundational primitives that we enjoyed from the previous generation. When you're building confidential computing workloads, you still don't have to change any code. CUDA code and AI workflows that work today work in confidential computing without any change for the application. There are, of course, orchestration delivery questions that you have to do when you launch the workloads. This gets to the attestation and where and how that's done. We'll touch a little bit more on that before. Of course, performance. Blackwell leading in with the GB300 class NVL16, I'm trying to remember all the numbers, is 7x more performant than the Hopper generation before, which, as I've just made the case, when we need 100x scale, is really important to see in the roadmap. We've improved everything we can lay hands on, really looking end-to-end, from tensor core performance at the lowest level, looking at memory bandwidth and scale out and performance through NIC and NVLink expansions for scale up and scale out to get to the largest form factors necessary to do this work. And then, of course, scale. If you look at, we have an RTX 6000 Blackwell server. It's sort of the Hopper single node SPT that you see today. We're releasing GA for confidential computing support on Blackwell in a little over a month. We expect to quickly follow with MPT, which is all the GPUs in a single node scale out following. You'll see that in the B300 and B200 server classes, and then going multi-node later after that. And if you have a workload that requires multi-node, I'd love to hear about it because that scale is definitely something we have our eye on. And then obviously trying to figure out trust. Now, this is a lot of bits and bytes for many people. You know, what is a 2.3 terabyte HBM mean to you? Probably not a lot. So let's talk about the industries. And I think all the industries that we've talked about last year are the same industries that we see today and more. And they're all sort of going through the same progression of AI and the evolution of AI. When we look at services, it used to be very focused on GDPR and marketing and constraints there. But those services are not just direct transactions and managing sort of who has the data and where does the data go, but now we're building full chatbots that are interacting with users and accessing their specific data. So we're going from generative to agentic, long context learning. In the healthcare industries, who've always quickly adopted sort of the regulatory and privacy-oriented technologies, are also expanding. You know, we look at healthcare and life sciences. They used to use compute for protein folding, direct computations. Now they're using AI estimators for toxicity. They're using LLM sequences to generate proteins and building full drug discovery pipelines using AI-enabled technologies, right? This is a huge shift. Even while the healthcare providers themselves are doing data digitization of the patient records and transforming the way they interact and deliver patient care to consumers, as well as creating new diagnostic models by collaborating across entities in ways that never could have been able before without tools like confidential computing. Pivoting over to financial services, again, sort of heavily regulated. They understand how this works, but they started in, again, collaboration models. How do we deal with fraud? You know, we need to look at network effects across many institutions. That's a challenging problem for privacy and regulatory concerns. But they are also re-evaluating and reimagining what consumer services look like. How do they engage with their users? How do they give advice? Financial processing are doing encrypted or secured enclaves to do payment processing, hardened enclaves to do the transaction processing and limit exposure of these very sensitive bits of information as they go through. All fantastic. And when we predicted back then that this would affect all industries, we're starting to see the beginnings of that as well. We look at public sector, we're seeing communications pushed to the edge using AI and adaptive technologies to analyze what's going on. In emergent markets, obviously autonomous vehicles are well known, but we're seeing robotics platforms, mobility there. We're seeing simulation in manufacturing, doing fluid simulation with AI against parts and pieces, or simulating fleets of robots in a warehouse. How do we do the planning and evaluation of that? Very agentic, all the same evolutions here. And this is really just making the case for everyone needs this capability. We're gonna need scale in a lot of different locations. It's going to be really important to pretty much every industry of how we build this out and what this looks like. And we talk about scale and trust. We're going to need both, I think, to really accelerate a lot of these markets, and really important to be focused here because I think confidential computing delivers all the key foundational pieces we need to succeed in that endeavor. And then coming up here, building trust. So all these things on the left, we have cloud deployments, we have hybrid cloud, we have on-prem, often sovereign cloud solutions. We have all this compute capacity. How do we connect it to these trusted workloads? Typically, that's through attestation services. And we talked about this need for scaling trust, and NVIDIA is certainly sensitive to that and how we go about doing that. We delivered live attestation services to the market with Hopper, as well as SDKs for integrations. We've continued to invest there. We're releasing in the next year OPA and Rego policies to make defining policies for these very complex agentic flows a lot easier and aligned with open standards in cloud and others to make that easily digestible for the operations teams that are inevitably going to be called upon to deploy these workloads. We've also added additional language bindings to the attestation SDK integrations because we recognize as we go agentic, there are a lot more types of software and modalities that we're going to want to support to, again, lower the cost and effort. And of course, we have third-party integrators like Edgeless and others who are in the middle trying to lower the cost and energy to activate these types of workloads, simplifying it while still keeping it secure and relying on these core attestation principles. So building trust for the future, there's so many emergent technologies here. Just as a random call, last week I was at GTC and spoke to this young entrepreneur at Neuralink who is sight impaired herself, building technologies into a car for autonomous vehicles to help sight or gain sort of indirect sight with narration of what the car is doing. Because if you're blind and you're moving around in a car, you have no idea what the car is doing. How do they participate? And finding even small cases like this of AI that allows accessibility. And really, for us, it's how do we make AI accessible to everyone, whoever you are, wherever you are, whatever your workload, is really critical and sort of our core mission here, because we believe in AI, we believe the impacts it can have on society and industry, and making that accessible is part of making it successful. So here we are, building trust for the future. I think we made a case. We need scale. We need trust. We're building AI factories now. It's no longer sort of dollars per CPU hour. It's millions of tokens per megawatt. And your cost is based, or your revenue is based on how many watts you can get into your data center. And we're very committed to building the scale and capability necessary for that future. We're excited to see the types of applications you all bring to the table. NVIDIA, not gonna lie, what we do is hard, but we also thrive solving those hard problems, and the expectations from the ecosystem are high. We're invested in it with you to help you deliver on your vision of the future, and I would love to hear from you all maybe next year what you've done in the last 12 months. If you have questions or would like to learn more about what we've done at NVIDIA for confidential computing, I invite you to talk to myself, Rob, somewhere in the room. Off to the side, we'd love to take questions, or go to www.nvidia.com/confidentialcomputing to learn about more of what we do. Thank you so much for your time today.